Hello, my name is Rex Congdon, and my partner's name is Wesley Johnson, and together we created an XY plotter for our Engineering 416 Mechatronics class at San Francisco State University, taught by Dr. Azadi, Assistant Professor of Mechanical Engineering. Our XY plotter is a two-dimensional CNC machine that draws along the X and Y axes by interpreting G code. All coding besides creating the G code was created on MATLAB. First of all, I will go over the mechanical design aspect of the X and Y plotter. This is the final sketch of the design. We went through a couple iterations before we decided on this one. The first iteration was based on a bearing and aluminum extrusion design, but after a couple runs, it was apparent that the aluminum created a groove on the plastic bearings we created and had to scrap the projects due to not tight tolerances. Thankfully, we had some linear actuators and bearing rods lying around to create our final design. These are the final dimensions of hole patterns and sizes for parts that we machined out. Every square on the grid pattern corresponds to 1/4 of an inch. All parts were either scrapped from packaging machines such as linear actuators or created on a 3-axis mill and lathe. These machines were home accessible for one of the team members. The materials that we used were Delarin, acrylic, and aluminum and steel to create the parts. These are the final manufactured parts for the X and Y axis. The motors and the belts were bought online, but the rest was either manufactured or scrapped from, as I said before, the packaging machines. Fiber optic sensors were used to home the CNC machine. From what we interpreted, the sensors recorded the amount of light reflected back out of 4200. Based on trial and error, we determined that 50 out of 4200 was good enough for the y-axis and 50 out of 4200 for the x-axis. And that landed us right where we wanted to be for the 8.5 by 11 paper to do our path calculations on our grid, which will be explained later in our slides. This is our final design. We have a holder on top for an iPhone, as this is what we use to take a picture of our computer vision algorithm. Displayed is the grid pattern for the green and red colors that we had to recognize to draw a line to the corresponding characters. Green has to go to E and red has to go to 4. This is our phase 1 design. As you can see, the left sensor has been calibrated to 50 for the Y and the right 500 for the X. The right pictures of our power supply. An Agilent E3638 triple output DC power supply that let us safely and accurately power our motors and sensors. Our CNC is powered by an Arduino Uno that is stacked with a CNC shield. The CNC shield connects the corresponding pins to the right outputs for our motors and for the actuator for lifting the pin. Gerbil firmware is uploaded on the Arduino Uno so that it can interpret incoming G-code commands from MATLAB, our main source of software. Next will be the software side of the CNC machine, how we created the GUIs and how the G-code is sent to our CNC machine.
So I'm going to walk you through how our phase 1 GUI works in order to identify and locate the red and green objects on the plotter. Okay, so these 4 buttons right here are the main functions of our GUI. The capture button will take a picture from our iPhone. Scan will use the pre-trained neural network that we built to find red and green objects on the grid. Encode will turn those object locations on the picture to physical locations on the grid and also turn that into G-code. And lastly, send G-code will send the G-code we generated from encode to the Arduino. Alright, so to start off, we have to enter the camera URL that is displayed on our iPhone. The app we are using is IPCam, which can be found on the App Store for about $3. Okay, and enter a COM port that the Arduino is connected to your computer. Alright, so pressing capture, we will get our picture from our iPhone. and by pressing scan, we can locate the red, green objects on the grid. Pressing encode will find the locations on the actual grid and turn that into G code. So right here, this red object right here is at BK 613, and the G code to get there is you have to move the plotter 187 millimeters up and 141 millimeters across. And all this G code is in absolute position, so it's not adding on to any position that it's at. So say if it's already over here, it'll just move to this coordinate right here. So it's a coordinate, not adding on positions. Okay, and lastly, send G code will send the G code that we just generated to the Arduino and move it to the red and green objects and connect the red objects to 4 and the green objects to E, and then back to 0, 0. And we're going to show you that right now, how it looks on the actual grid. Now I'm going to walk through the phase 2 functions of our project. So this right here is our GUI that we made. This first tab right here, machine control, will allow you to open communications with the Arduino and to unlock or home your system. Most of these ones aren't working right now, but we are currently going to add the functionality to control Gribble a lot better. So draw a circle. You can enter a radius for your circle. So for a 5 centimeter circle, we enter 50, and we can center the circle anywhere we want on the paper. And then once we have these parameters done, we could press draw circle to automatically send the G code and to the Arduino and draw a circle. Draw square. So for this one, we can enter any lengths we want for the sides of the square. So for 10 centimeters, we enter 100, and we could start drawing the square at anywhere we want as well. So we start at 10 millimeters by 10 millimeters. And what this means is that the bottom left corner of our square is going to start at 10, 10 and also end up over here once it's finished drawing. And then once we have all these, press draw square to automatically draw the square on the paper. Okay, so write text also has the same type of flexibility in the sense that you could write whatever text you want in this line right here and print it out. So right now we have the functionality to write any capital letter from A to Z, numbers from 0 to 9, and exclamation point, hashtags, @ symbol, %, and question mark. And this word start x-axis and word start y-axis determines the location of where the E will start. So if we put in 80 by 2 millimeters, this E will start writing at this location right here. And then the rest of the words, or rest of the letters will start writing horizontally at the same Y position, but the X will change. And press right to automatically generate the G code and send it to the Arduino. Lastly, the draw image will allow us to pick any G code file we have in our directory over here and send it to the Arduino. So we're not actually creating the G code itself on MATLAB, and we generate the G code for the SState logo on Inkscape instead, because we weren't able to create a function that could interpret the SVG file and make G code for it. So yeah, we picked the SVG G code file we have from this drop down menu, and then we press send G code, and the file will, the Arduino will start drawing the SState logo. Okay, and now that we ran through the functionality of our GUI, we will show you how each 4 of these functions work on the actual plotter itself.
Here at Brymar College, we can get you prepared for the 31st century with advanced programming in quad rendering and Java++ scripting language. We offer advanced job placement assistance. So upgrade your grain matter, cause one day it may matter. Upgrade your grain matter, cause one day it may matter. Upgrade your grain matter, cause one day it may matter. upgrade your gray matter, because one day it may matter.
Coming from the outer regions of the universe, Deltron Zero and Automator. Check it. Upgrade your gray matter, cause one day it may matter. Hey, time for you to upgrade. Fuck save, time to load all my rhymes to sold and find your own. Salivate over what I collaborate with high-tech wizardry and breathe new life into the industry. Save to the hard drive for the archives. 3030 with a global apartheid. Sensitivity ain't the energy. Brain chemically contorted with no coordinates to your ordinance. Upgrade your gray matter, cause one day it may matter. Yo, your recovery slow. My dual input plus my modem, the tool send foot. Long songs, instrumental, digital projector. Professor, I school you on the art and how it's texture map. Get to act together, my style is mega. Educate the heads of 8 lonely beggars. Only shred of evidence is the virtual file. Stored within the cerebellum, hit you burger with style. Upgrade your gray matter, cause one day it may matter. My defense capabilities with ape agility. Take possibilities to the point to senses shattering. Commence the babbling, I'm meditating on a homo sapien. With no education, I'm 3D acceleration. My programming language is the strangest to come to grips with mechanized mischief. Kicks it off with circular projectiles, X-Files. Herald as the most important, dwarf the corporates. Upgrade your gray matter, cause one day it may matter. I reduce the game when I boost my brain. What you used to saying, I loosen the frame with shock announcements. T-minus and counting, effects controlling bouncing. Star-studded and flooded like fountains. A new machine, real artists are few between. You better lube your screen. My renders are splendor 360, reflecting quickly. Increase your disk speed so you can upgrade your gray matter, cause one day it may matter. My production model is the stuff that boggle minds. You got a log on time of exactly 36 nanoseconds. Ambidextrous with ambience. Watch the cannons twist while I lock out my hardware. Word warfare, logistically locate and process with psychotropics to optimize my profits. Envelop you with development kits to help me to embellish the elements, dynamic and too intelligent. Upgrade your gray matter, cause one day it may matter. Looky here, as soon as I release the chip, you cease to rip. Synopsis, you wanna top this? Reach to it. Digital retouch, reconstruct a whole conglomerate with our armaments we use with tolerance, such as a G-bomb. Cyborg with 3 arms. Translate the...
Thank you for watching from Rex and Wesley Johnson, Engineering 416 Mechatronics, San Francisco State University, undergraduate of Electrical Engineering.